welcome back. Today we're gonna be doing Sigma notation and series. Sigma notation and series. So yeah, let's get to it. Uh, so yeah. So Sigma notation is used to indicate the sum of terms given by this this, yeah, you can call it a symbol or some, yeah, a symbol. So at the bottom it's like k equals to 1, so this is our initial value. This is the start, where we start our term 1, the first term, let's say, yeah, the first term. So this is our first term. It represents our first term. It means we start at 1. We start at 1, yeah. So n equals to 3 is our last term, so it means we're gonna start at 1, then we're gonna have 2, then we're gonna have 3, which is our last term. So it's gonna be n equals to 3. So tk represents the total of the sum. Sorry, tk represents total of the sum of the sequence. Like when you add from tk up to n, so tk represents the sum of all the terms, like the first term, the second term, and the third term. It's their total. So n represents the formula of the sequence. So we know that our sequence starts from 1 and ends at 3. So for the first one we're gonna have 1, for the second one we're gonna have 2, for the third one we're gonna have 3. So the total of all these numbers or terms, we can say it's 6, because like if you add them all it's gonna be 6. So that's why here the total of the sigma notation, or the summation of all the terms, is equals to 6, because like if you add the terms from 1, 2 and 3, then you get a total of 6. So this is what sigma represents. It represents the sum of all the terms in a sequence. So yeah, this is what sigma notation is all about. So now we are in series. So series is like sigma notation for the arithmetic. So it's like you add all the numbers and you find their total. So yeah, here we have a formula for the notation. So let's try and use it and see how we can use the formula to calculate the total of the sum. So from the previous one we know, like for our 3 times we had like 6. So now let's try and calculate and see if we can get something. So let me come here. So gonna come here and we're gonna say our number of terms was 3 that time, then divide by 2, then here we have our first term was 1 plus L was our last term, which is 3. Then we close the thing. Then you can just copy this one and just say copy, then paste this. Copy the whole thing and just yeah. So now from here, so yeah, let's see. Then it's gonna be 4. Then as you know, it's gonna be 4 times 3, which is 12. So this is how we use the formula for the sum. So this is the same as sigma notation. So that's why I said about the arithmetic series. So even this one like still applies. You can like put the formula, change the numbers. Difference will be 1. Then yeah, you can check it out yourself. If you have a problem, just tell us. So the last part we have is geometric series. So as you know, geometric series uses the ratio whereby r equals to this is how r we define r. So yeah, we know this is r. Then you come here, then let's try and use this one also and see, because mostly our program is mostly about practicing. So you guys have to practice. So you can't just learn these things and not practice. So yeah, you have to practice, guys. So yeah, so here let's calculate. Let's say we have 2 or let's say 6. So yeah, this is, let's say this is our pattern. So we know, so our r, let's see, r equals to divided by 2. This will be divided by 4. So yeah, if we come here and we substitute, so let's say we have 3 times then our first time is 2, r is 2 to the power, let's see, 3. Two. So 7. So as you can see now, 2 plus 4 plus 8 will give us 14. So now you know how to use geometric sequence. So let's see what do we need. Sum to infinity. Let's see, a convergent geometric series with the ratio between -1 and 1 tend to certain fixed number as a number of set. So this means like for the ratio between -1 and 1, so it means like the series will approach a number, but it will not reach that number. So it will always converge towards a certain number, but it won't approach that number, because if it approaches that number, it's going to be 0. So yeah, that's what sum to infinity means. It converges. It's like if you divide 2 ka half, you for 1. If you divide the 1 ka half, you for half. If you divide the half ka half, you for a quarter. Quarter ka half, you for half quarter. Until there's gonna like auto divide. We are go pay. There's all like there's no way how answer over 0. So you converge towards 0. Maragas reaches 0. That's what sum to infinity. So yeah, thank you. Okay, this is the first chapter, sequence and series. So we are done with this one. So from now on, we're gonna do practicals and stuff. So we're gonna read going forward.